Let's talk about second challenge now, release automation. So what was the goal, what we tried to achieve as a part of this challenge? So as a part of this challenge, because as I was saying, this is the cross-platform command line tool, I want to create a self-sufficient build which I then will be distributed somehow across all of my users, and I want to create this self-sufficient build for all the three platforms, Windows, Linux, and macOS. So again, how we approach that? We started with the first iteration, and what we had as a part of the first iteration, we had something like this. So this was our release pipeline. So that was basically the task. As you can see, that's the same .NET Core CLI with the publish command and a set of attributes. But what is really important actually to highlight here is this build platform variable. So if you can see at the arguments, you have the build platform variables, and that was basically the outcomes from this exercise, from this iteration. So first of all, that approach worked, but the question, which is still remains unanswered, how you will provide the different values for build platform variable, because you need to provide the Windows, the macOS, and the Linux value. And it comes up with, guess what? Copy-paste driven development again. But as we all remember, I am not the biggest fan of that. So that is why let's try to take a look at the second iteration of this second challenge. So what we did here to basically maintain the same approach of building our application, but with different configurations, we utilized another cool feature of the build pipelines, which called the parallelism and the exact matrix strategy for that parallelism. And it looks like this. So on the job level, you define your strategy, and you said that my parallelism strategy will be matrix, and then I defined kind of an items for that matrix. In my case, it's Linux, Windows, and macOS. And for each and every value in that matrix, I define a set of my environment variables. So as you can see, the name is always the same, but the value is always different. So that's Linux, that's Windows, and that's macOS. As an outcome of this second iteration, it works again, which is again awesome. And matrix parallelism strategy, as I was explaining, basically enables us to repeat the same set of steps but with different values. And now let's take a closer look how it actually looks in real life. So currently on your screens, what you can see, this is basically the pipelines which I use to handle my release automation. Let's take a bit closer look. So first of all, as you can see here, I disable all the triggers, so currently this pipeline can be run only manually. Then I define my first stage, which is called release, and I have one variable here called path to project. What is important is that under the jobs section, I have my job called publish, and here I define the strategy of the parallelization for this job, and I use the type of this strategy called matrix. And I define three different rows in this matrix. That's Linux, Windows, and macOS. And on top of that, as you can see, I use the same key called build platform, but with different values. So that basically means that this job will run 3 times, and for each and every run, it will use either Linux or Windows or macOS value for this variable. Then I choose the build agent pool, basically the image of my build agent, and here I'm using Ubuntu. This is also kind of interesting stuff that I can still build the binaries for Windows and for macOS using Ubuntu. This is what I can do with the .NET Core. So then, as I was explaining before, my application is written in a way that it's highly depends on the exact version of the .NET framework. So that's why here I need to specify again that I will use version 2.1 latest. And here is basically the tasks which handles all the magic. So this is the regular .NET Core CLI, and I use the command called publish. There are a few arguments that I need to pass into this command. The first argument, -r, and here I pass the build platform. And this, as you can see, is the same notation as you can use for any other variable. And this is basically means that I will run this .NET publish with 3 different values of this build platforms. Then I say that I want this build to be self-contained, so basically I want to include .NET runtime into my build outputs as well. I want to use the release configuration, and as an output folder, I specify some staging folder, which I will be needed a bit later during this build. So then I have 2 activities. I'm doing basically copying files back and forth. I'm copying the shared files that needs to be a part of that deliverables, of a part of that package that I will then redistribute across all my users. And also I have some platform specific files that also needs to be a part of that package that I will redistribute later. And then the final task on this stage in this pipeline, it's called publish build artifacts. And here I'm basically grabbing that staging folder that consists of the binaries, basically the output of my build, and shared and also platform specific files that I copied that as well. And then I publish that as an artifact so I can use that later. What also worth mentioning here, that here I can define my second stage and I name it deploy. And as you can see here, I also said that I want this stage deploy to be dependent on the release stage. So what I meant actually to implement here is that after I build all those binaries, all those packages for different platforms, I want to grab those and then upload it back to the GitHub so each and every user potentially can download it from there. For now, it's not implemented, but that's not the point of this talk. The point of this talk is to basically show you that if you want to have a few different stages in your pipeline, that's what Microsoft called the multi-stage pipeline, you can do it like this. And you can also specify the dependencies between those stages. So here in my case, the deploy stage will sit there and wait until the release stage will be done. Another example that I can give to you from the, let's say, more or less daily activities that you may have in your project, if you want to deploy your application on different environments. Let's say you want to deploy it to the dev environment first, then you want to deploy it to the QA environment, then you want to deploy it to the UAT, staging, production, and so on and so forth. You can define those as a stages, and you can say, for example, that my QA stage depends on my dev stage, which will basically mean that only when the dev stage is done, and only if dev stage is basically all green, only in that case the QA deployment will actually happen. So what I will do now, I will basically hit the run button and I will show to you what will happen when we will run this pipeline, and then we will also analyze the results together. So let's run it, and now we need to wait just for a few moments to give this pipeline enough time to execute. The pipeline has finished, so as you can see there were 2 stages, release and deploy, and as you were able to see, basically the deploy stage waited here until all the parts of the release phase basically finished their job. And also what is worth mentioning is that each and every part, as you can see, took a minute and a half, more or less on average, and the release stage itself took also a minute and a half. So that basically means that all of those were executed in parallel, and also when all of those are done, only after that the deploy stage actually took the control and start implementing those tasks that we stated within this stage.